My name is Nicholas Pelham, and my CS120B project is the core functionality for a programmable quadcopter. I got the DC motors out of a cheap RC quadcopter that I took away all the electronics for just so I could use the frame and the motors and the blades themselves. The motors are DC motors that are geared so that the motor spins much slower than the blades do. I plan to put an accelerometer on top of this so that the axes are lined up with the arms of the frame so that each axis only controls 2 motors. This allows it to easily sense when one motor is higher than the other, and it will slow down the higher elevation motor and speed up the lower one to correct the tilt and hopefully have it hover in place. I also intend to put on sonar sensors on the front, right, back, and left so that it can avoid obstacles. When an obstacle is detected, it will speed up the motors that are closest to the obstacle and slow down the motors that are furthest away so that it will tilt away from the obstacle and then fly away from it until it's a safe distance where it will hover again. The sonar sensor functionality takes priority over the hovering functionality so that it will stay tilted until it is away from the obstacle, and then it will hover again. So now for the more technical side of the video, you can see here all the components that were used in this quadcopter. You can see the frame here and the motors that I showed off in the earlier part of the video, as well as the ATmega 1284 that we're using to control everything, the SparkFun Electronics accelerometer, and each of the sonar rangefinders. If you consider the white blades to be the front of the quadcopter, this is for the front, the right, the back, and the left. There's also transistors here that are hooked up to power through a DC regulated power supply that's slightly off camera because the motors themselves draw much more current than either the ATmega can supply or this power supply from class can supply. If I ran it just off this, you would see this LED turning on and off as the motors spin up to full speed because it draws way too much power. Now, I had intended to put all of this onto a board such as this so that I can attach it to the quadcopter. I still will eventually, but I couldn't do it due to time constraints and some issues with the electronics that you're about to see as I turn them on. Now, one of the other reasons that I need 2 power supplies is actually because this accelerometer runs on only 3.3 volts, while the motors run on 5, as well as the chip and the sonar sensors. Most notably, the sonar sensors don't actually operate at 3.5, where everything else would, but not as well. So I have to turn on both of them. And you can see immediately that there's a problem because this is stationary, but obviously it thinks that it's leaning, and that's why 2 of the motors are on while 2 of them are not. But you can see that it does react appropriately as I tilt this board and tilt the accelerometer, so I can turn this axis to this motor on and this one off. If I tilt it on the other axis, I can turn this motor off and this motor on. Like I was saying, the rangefinders actually take priority. So even though it thinks it's leaning, this is the front, so the front is on. I would do this one, but it's just going to turn the motors on that are on anyways. Here's the rear. Here's the left. And you can see that it's taking priority because right now it thinks it's leaned, and these should be on if there's nothing detected, which you'll see happen right now. So that's basically the functionality that I have at the end of this quarter-long project. As you can see, there's still some work to be done before I have a flight-ready prototype, but I did achieve the 3 main goals that I set out for myself in this project, which was to have working DC motors, a working accelerometer, and working sonar rangefinders that all operate together to give me the basic functionality that I was looking for. There's just a few little kinks to iron out before I can make it hopefully hover and fly on its own for that basic core functionality for what will become a programmable quadcopter that will fly and do other things. If you would like to see the code that I used for this project, I'll link to my GitHub account below in the description. You'll probably be able to find it under a tag for CS120B for this particular release. Hopefully I'll still be working on this, so it should be far beyond that by the time you actually look at this in the future. I've been Nicholas Pelham, and thank you for watching.